Okay, so welcome back. And so now what we're going to do is we're going to do another example of rotating a curve, a parametric curve, around the x-axis. And so here's the parametric equations that we're going to use, and this is the interval for t. Okay, so in this case again we're going to use the formula for surface area for our parametric curve is going to be the integral from a to b of y of t times the square root of the quantity x prime of t, quantity squared, plus y prime of t quantity squared dt. And so again, I'm going to just plug in what I know. So we're going from 0 to 1. Y of t, that's t squared. Okay. Then the square root of x prime of t is 3t squared. Quantity squared. Plus y prime of t. So y, the derivative of y of t is 2t. Quantity squared. dt. And so now this is going to go from 0 to 1, and now that we got everything in there, now we just need to simplify this. So this is going to be t squared times the square root. What are we going to get? We're going to get 9 t to the fourth, right? We're going to get 9 t to the fourth plus 4 t squared. dt. Okay, so now what are we going to do? Let's keep simplifying. So this is going to be 0 to 1, and we're going to factor out, just let's see, make sure, yeah, so we're going to factor out a t squared. So this is going to become t to the t squared times the square root of t squared times 9t squared plus 4. dt. And then this is going to become the integral from 0 to 1. And so this is just going to be t, right? I can split this off. This is just going to give me a t. So this is going to be t cubed times the square root of 9t squared plus 4 dt. Okay, so now, what do we have here? I can do a u substitution, I believe. So let's do a u substitution. So u equals 9t squared plus 4, which means du is going to equal 18t dt, which means I can change this to 1/18 du. Now, I've got a t cubed, but that's fine because I can rewrite t squared, right? So t squared is going to equal u minus 4 over 9. Okay, so let's see what that gives us. Okay, so let's write this in terms of u. And again, when t is 0, u is equal to 4. Okay, so when t is 0, u is 4, and when t is 1, u is 13. And so now this becomes what? It's going to become 1/18th, 1/18th, okay, du, and then I'm going to get u minus 4 over 9 times the square root of u du. Okay, all right. All right, so now I'm going to pull out the 9. So watch what happens here. So this is going to go from 4 to 13, and I'm going to pull out the 18. So this is going to be 1 over 162. Right? So 9 times 18, so 9 times 10 is 90, 9 times 8 is 72, 72 plus 90 is 162. So I get 1 over 162, and in here I'm going to distribute this. So this is going to give me u to the 3 halves minus 4 u to the half du. And so, oh, I keep dropping this 2 pi. Sorry. 2 pi. 2 pi. 2 pi. Don't forget the 2 pi. 2 pi. 2 pi. And this is going to give me 2 pi. And here I get 2 pi. Okay, so I'm going to end up with 2 pi over 162, oh, du, right? Okay, so now, so I'm going to simplify this one more time. So again, 2 over 162 can reduce to 181, so pi over 81. So this is going to be pi over 81. And then I can integrate each one of these. So this is going to give me 2/5 u to the 5 halves minus, so this would be 4 times, so this is going to be 3 halves, right? So it's going to be 3 halves, so 2/3 u to the 3 halves. And that's going to be from 4 to 13. Okay, so far so good. So now, I'm going to evaluate this as 13 and 4. So this is going to be pi over 81. And it's going to be evaluated 13, so this will be 2/5 13 to the 5 halves minus 8/3 times 13 to the 3 halves minus pi over 81. Now it's going to be evaluated at 4. So this is going to be 2/5 4 to the 5 halves minus 8/3 4 to the 3 halves. Okay, now we just need to simplify this, and find what the exact answer is going to be. So what's this? This is going to be pi over 81. And let's see what we can do here. So this is going to be 2/5. This is going to be, let's see here, the square root of 13 to the 5th minus 8/3 square root of 13 to the 3rd minus pi over 81 times, now this one's going to be easier because 4, so I can take the square root of 4, right? So this is going to be the square root of 4 quantity to the 5th minus 8/3 square root of 4 to the 3rd. Okay? And now I get pi over 81. This, I can just expand this out. This is going to be 13 squared times 13 squared times 13 minus 8/3 times the square root of 13 squared times 13 minus pi over 81. Okay, so what happens here? This is the square root of 4, which is 2. 2 to the 5th power is 32. So this is going to be 2/5 times 32. Now, here this becomes 8/3, and this becomes 2 to the 3rd power, which is 8. Okay, so now we're getting to the end. So now this becomes pi over 81. Now here, this is going to be 13. This is going to reduce to 13 because I can take these out of the radical, right? So I can split these up into product of radicals. So this is going to just reduce to 13. This is going to be 13. So what I'm going to end up getting is 2/5 times 13 squared times the square root of 13. Okay, minus 8/3 times 13 times the square root of 13 minus pi over 81 times, now this is just going to become what? This is going to become 64 over 5 minus 64 over 3. Okay? Okay, so this is going to be 169 times 2. So 169 so 169 times 2 is 3. $338 over 5 times the square root of 13 minus, this is going to be, so 80 plus 24 is 104, so this will be 104 over 3 times the square root of 13 minus pi over 81 times 64 over 5 minus 64 thirds Okay, so now we just got to clean it up, get common denominators, and simplify this. Okay, so I get pi over 81. I'm going to factor out the pi over 81. And so what does this end up giving us? This gives us 338 over 5 minus 104 over 3 times the square root of 13 minus 64 fifths minus 64 thirds. Okay. Okay, so now what is this going to be? This is going to be pi over 81, and this is going to end up being oh, hold on. So 1014 minus 520 over 15 times the square root of 13 minus, this is going to be what? 192 minus 320 over 15 and so we get pi over 81, and so what does this become? This becomes what? So 494? Yeah, 494 over 15 times the square root of 13 minus, well, this is going to be plus because subtracted, this is going to be negative. Okay, so 320, so that's going to be 128. So 128 over 15. And let's see here. Yep, that's it. So this is the way I leave it. I don't think you can simplify it any further. No, you can't. And so that's our final answer. And that is the surface area of the given parametric curve. Okay, have a great day.